So first, what is the neural networks? Neural networks are the machine learning models that mimic the complex functions of the human brain. And these models consist of the interconnected nodes or the neurons that process the data, learn the patterns, and enable the tasks such as the pattern recognition and the decision making. Simply, a neural network is a component of artificial intelligence which acting as an algorithm which are designed to recognize the patterns and the relationships in data, mimicking the structure and the function of a human brain. So simply as we are talking about as the human brain works, as the system will work. So they are particularly important when we are talking about in the machine learning models or the deep learning models where the large data sets to make the predictions, where the particularly a machine will learn from the large data sets to make the predictions or classify the data. So how we are talking about the neural networks in a deep learning. Neural networks are capable of learning and identifying the patterns directly from the data. Unsupervised data without predefined rules, without being unlabeled data, without the labeled data, and these networks are built from the several key components. What key components we are talking about here? First, the most important components, which is the basic unit of our brain, is the neuron. So, first component here we are talking about the neurons, the basic unit that receive the input. Each neuron is generated by thresholds and an activated function here. Then the connections are there between the neurons. So the links between the neurons that carry the information we regulated by the weights and the bases is here. Then we are talking about the weights and the bases. These parameters determine the strength and the influence of a connection. Then the propagation function. In the propagation function, we are seeing there mechanisms that help process and transform data across the layers of neurons. Then the learning loop, the method that adjusts weight and biases over time to improve the accuracy. So the learning in neural networks follow a structured three-stage process. What a structured three-stage process is: input, computation, output generation, and the iterative refinement. The data is fed into a network, and that data, based on the current parameters, the network generates an outputs in an iterative manner. How in an iterative manner? The network refines its output by adjusting the weight, gradually improving its performances under diverse tasks. So in adaptive way, the system will adapt. So in an adaptive way, the learning environment is the neural network is exposed to a simulated scenario or a data set or an environment or the situation. According to a situation, it will perform the output. According to the problem statement we are talking about here. So the neural network is exposed to a simulated scenario or a data set. So the system is adaptive in nature. The parameters such as the weights are updated in response to a new data or the conditions. The system is updated accordingly to a real data analysis are performing there, a real time analysis are performing there with the help of which the system is kept updating at every second. So the data which has been generated. And with each adjustment, the network's responses evolves, allowing it to adapt effectively to different tasks or the environment. So what are the importance of a neural network? Neural networks are pivotal in identifying the complex patterns, solving the intricate challenges, and adapting to a dynamic environment. Their ability to learn from the vast amount of data is transformative, impacting the technologies like the natural language processing, the self-driving vehicles, and the automated decision making also. So the neural networks streamline process, increase the efficiency, and support the decision making across the various industries. As a backbone of artificial intelligence, they continue to drive the innovations, shaping the future of a technology. So neural networks are the streamlined processes, increase efficiency, and support the decision making across the various industries because in which, as a backbone of artificial intelligence, they continue to drive the innovation, shaping the future of a technology. So what is the evaluation or the history of a neural networks? Here we are talking about. The neural networks have undergone significant evaluation since their inception in the mid-20th century. Here is a concise timeline of a major developments in this field. What we are talking about here in 1940s to 1950. The concept of a neural networks begins with the Mackintosh and the Pitts introduction of the first mathematical models for the artificial neurons. However, the lack of computational power during that time posed significant challenges to further advancing. In 1960 to 1970, the Frank Rosenblatt worked on the perceptions, and the perceptions are simpler perceptrons work on the perceptrons, which work on the perception. The perceptrons are simple single-layer network that can solve the linearly separable problems but cannot perform the complex task here. Then we are talking about the 1980, the development of the back propagation by the Norman Hart, Hilton, and the Williams revolutionized the neural network by enabling the training of a multi-layer networks, and this period also saw the rise of a connectionism, emphasizing the learning for the interconnecting nodes also. Then in the 1990s, the neural networks experienced a surge in popularity with the applications across image recognition, finance, and the more. However, this growth was tempered by period known as the AI winter, during which the high computational cost and the unrealistic expectations dampened progress. And in the very first unit, we have talked about this AI winter. Now, in the 2000, our resurgence was triggered by the availability of a larger data sets from the 2000 when there is an internet everywhere. The larger data sets are there. Advances in the computational power and the innovative network architecture. There we are talking about the deep learning utilizing multiple layers proved highly effective across various domains here. In 2010, the landscape of a machine learning has dominated by the deep learning with the convolutional neural network CNNs and excelling in image classification and the RNNs, which is the recurrent neural networks, LSTMs, and the GRUs gaining traction in sequence-based tasks like the language modeling and the speech recognition. Then from 2017, we are talking about the transformer models introduced by the Dasani. And attention is all you need revolutionaries by the natural language processing by using a self-attention mechanism for the parallel processing, including efficiency models like the BRT, GPT, and the T5 set new benchmarks in the machine translation and the text generation. So layers in the neural network architecture, what are the layers? What architecture we are talking about here? This is the input layers with the output layers and in between very complex layers of the connectivity you are imposing where each and every input is connected to each and every other hidden layers. So different hidden layers are there, input layers, hidden layers, and the output layer will be considered in the neural network architecture. So in the neural network architecture, we are saying that input layer, this is where the network receives its input data. And each input neuron in the layer corresponds to a feature in the input data. Hidden layer. Hidden layer, these layer perform most of the computationally heavy lifting, where we are talking about the computationally power. A neural network can have one or more hidden multiple layers, and each layer consists of a units, which are the neurons that transform the input into something that output layer can use. And in the output layer, which is the final layer, produce the output of a model The format of these output varies depending on the specific task, that is the classification or the regression we are talking. Now, how the neural networks work? What is a propagation? What is a forward propagation, or what is a backward propagation? So when the data is input into a network, it passes through the network in the forward direction. We have discussed many times in the second unit also, and in the fourth unit or third unit also, about the forward changing and the backward changing in the searching technique also. That's related with the forward changing and the backward changing. So when data is input into a network, it passes through the network in the forward direction. From the input layer through the hidden layer to the output layer. This process is known as the forward propagation. This is what happened during this phase when we are talking about the linear transformation. Each neuron in the layer receives the inputs, which are multiplied by the weight associated with the connections. And these products are summed together and is added to the sum. And this can be presented mathematically, like you can see here the equation, where WW is representing the weight and XS is representing the inputs and the VB is representing the different axes. So what do you understand by the activation? The result of a linear transformation, which is generated by a ZZ, is then passed through an activation function. And the activation function is crucial here because it introduces the non-linearity into a system. We are talking about here. We are here. And enabling the networks to learn more complex patterns here. The popular activation functions we are talking about here, the sigmoid and the tank here and the REM. If we talk about the sigmoid, what do you understand by the sigmoid? Sigmoid function is simply a S-shaped curve. Here we are talking about, or a mathematical function used as an activation functions in the neural network, where we are talking about the mapping any real valued input to a value between 0 to 1 after interrupted as a probability. So here we can relate it to the probability theory or the probability reasoning that we have talked about in the third unit also. Another working of a neural network is a back propagation, where after the forward propagation, the network evaluates its performance using a loss function, which measures the difference between the actual output and the predicted output. We have discussed this in the yesterday lecture also. The goal of training is to minimize the loss, right? We have talked about it in the utility problem also. When we are talking about the learning by the problem solving, this term we have talked about in the utility problem also, or in the parameter adjustment also. The goal of training is to minimize the loss, and this is where the propagation, back propagation comes into play. Loss the calculation, the network calculates the loss, which provides a measure of error in the predictions. This we have talked about in planning also. So the loss function could vary. Common choices are mean squared errors for the regression task, or the cross entropy loss for the classification. Then we are talking about the gradient calculation. The network computes the gradients also of the loss function with respect to each weight in the network, and this involves applying the chain rule of calculus to find how much each part of an output error can be attributed to each weight. So simply here we are talking about what has going to be wrong, what has, how can it be back propagated. The weight update, once the gradient are calculated, the weight are updated using an optimization algorithm like the stochastic gradient descendant or the SGD. The weight are adjusted in the opposite direction of the gradient to minimize the loss, or the size of the step taken. Each update is determined by the learning rate. So, which will basically fail the plan will be back here. So, what is the iteration? And this is simply when we are talking about the iteration, we are talking about the forward approach. So, this process of a forward propagation, loss calculation, Backpropagation and the weight update is repeated for many iterations over the datasets. Once the forward propagation will be there, once the output will be generated, then the loss calculation will be done. And if there is any loss, the backpropagation will be done. And according to that, the weight will be get updated. And again and again, these steps will get repeated in many iterations over the datasets. Over time, this iterative process reduces the loss, and the network's predictions becomes more accurate via time. As a via time, the more accurately the network predictions will be done. Through these steps, the neural networks can adapt their parameters to better approximate the relationships in the data, thereby improving their performance under tasks such as the classification, regression, and any other predictive modeling. So what are the examples of an email classification are here? Let us consider a record of our email data sets we are talking about here. Simply, here we are talking about an example. To classify this email, we will create a feature vector based on the analysis of a keyword such as a free, win, or offer. We have talked about the spam email searching also. The feature vector of the record can be presented as a free present one, win absent zero, or offer as a present one. Or the email content, here is the email ID, get free gift card now from a spam. Sender is a spam example.com. Subject line is the exclusive offer, or the feature vector can be 101 and the label is 1. So how neural process data in a neural networks? In the neural networks, input data is passed over multiple layers, including one or more hidden layers, and each neurons in these hidden layers perform the operations, transforming the input into a usable output. When we are talking about the input layer contains the three nodes that indicate the presence of each keyword, which keyword we are talking about here, free, win, and the offer here. The hidden layer, the input data is passed from one or more hidden layers, and each neuron in the hidden layer performs the following operations weighted by sum. Each input is multiplied by the corresponding weight assigned to the connection. For example, if the weight from the input layer to the hidden layer neurons are as follows. Weights for the neurons. H1 0.5 minus 0.2 to 0.3 here. Then the weight for the neurons H2 0.4, 0.1 minus 0.5. Let these are the weights are the inputted from the input layer. Now calculate the weighted input, which is the weighted input. So we are calculated here for the H1 is the 0.8 and for the H2 it is 0.1. So the activation function, what will be done? The result is passed to an activation function to introduce a non-linearity. For H1 it is 0.8 and for H2 it is 0. So the output layer, the activated output from the hidden layer are passed to the output neuron, and the output neuron receives the value from the hidden layer and the neurons and complete the final predictions using the weight. Suppose the output weight from the hidden layer to output neurons are 0.7 and 0.2. So here the calculation will be done according to that 0.8 multiplied by 0.7 multiplied by 0 multiplied by 0.2, which is equal to 0.56 plus 0, 0.56, or we are simply taking it as a 0.5656. So the final activation will be done. The output is passed to a sigmoid activation function to obtain a probability where it would be approximately 0.636. So the final classification will be done. The output value of the approximately 0.636 indicate the probability of the email being spammed here. Since this value is generated or the greater than 0.5, so the neural network classifies the email as a spam as a random function. Simply how we can define here with the help of a email classification example or the spam probability function can be included in your assignment question also. So you need to understand very this what can be the input layer. The input layer can be the free, where the probability of a free is there 0.5 to 0.4, win is the minus 0.2 to 0.1, offer is 0.3 minus 0.5, and the hidden neurons or the hidden layer where the two neurons H1 and H2 will be calculated based on the value, so based on the input layer. which has been calculated as a 0.7 to 0.2 with the help of a sigmoid function. The scan probability will be calculated in the output layer. So in the learning of a neural networks, we are saying that learning with a supervised learning can be there, learning with the unsupervised learning, or the learning with the reinforcement learning, as we have talked about in the machine learning. So what are the types of a neural network? There are 7 types of a neural network that can be used: feed-forward network, single-layer perception, multi-layer perception, convolutional, convolutional neural networks, recurrent neural networks, and a long-term neural or long-term short memory gain. Let's talk also about this. And in the next lecture, we will talk about the genetic algorithm, and our 4 minutes will be with complete. So in the feed-forward network, what we are saying there, the feed-forward neural network is a simple artificial neural network architecture in which the data moves from an input to output in a single direction. No multiple directions are there. We are not talking about the backward propagation here. In the single layer perception, a single layer perception consists of only one layer of a neuron. So it takes inputs, applies the weights, and sum them up, and then use an activation function to produce an output. In the multi-layer perception, we are saying that is a type of a feed-forward neural network with 3 or more layers, including an input layer, one or more hidden layer, and an output layer. It uses non-linear activation functions. So in the next lecture, we will talk about the other neural networks also and the genetic algorithm.